Hello guys, welcome to Math2Go. Today we are given this matrix here, and our goal is to determine the kernel of this matrix. So let's start now, immediately. So as always, you would like to have here an upper triangular form. I was also mentioning this in my previous videos. If you're interested, you can watch them. I will link them down below into the description. So, how we can achieve here to get zeros? So basically we need to multiply the first row by 5 and subtract the second row, and then we can get a 0 here. So the first row by 5 and then subtract the second row. We will leave the first row as it is because we don't need to have any zeros there. And then we have 5 times 5 minus 25, this is 0. And then we have 1 times 5 minus 5, this is also 0. And we have 3 times 5, this is 15, minus 15, 0 again. Okay, so we need to get a 0 here as well. How can we get it? We need to multiply the first row by 2 and then add it to the third row. So the first row by 2 and then add the third row. And then we get a 0 here because 5 times 2 is 10 plus minus 10 is 0. And then we have 1 times 2 plus minus 2, this is 0. And we have 3 times 2 plus minus 6, this is 0 as well. So we have a very unordinary matrix here given now. And for some people it's not so easy to determine the kernel here because the kernel is not so obvious. Let's draw this line here because it's helping us. And then we can imagine to have here x, y, and z. If it's helping you. So again, we are looking for the values x, y, z such that the matrix is mapping them to 0. You can read out actually, z times 0 is 0. So this means z can be any real number, and let's call it t. Because at the end you would like to express x, y, and z as numbers or parameters like t. And t is any real number. So the second row then reads 0 times y plus 0 times z. 0 times y plus 0 times z equals 0. And this is equivalent to 0 times y equals to 0. And this means also y can be any real number, and let's call it s. So now we are heading to the first row. So this must be a bit more spectacular here. 5x plus y plus 3z equals to 0. And we have some values for y and z now. Because our goal again is to express x as constant values, parameters, numbers, independently of y and z. So then we have 5x plus s plus 3t equals to 0. And we can bring everything to the other side. This is giving us x equals to minus s minus 3t. And this is all divided by 5. Let's write it like this. So the solution is then the following set. It is x, which is minus 1 over 5s, and minus 3 over 5t. And then we have y as s and z as t. And s and t are real numbers. So we are already done here. This is the kernel. This is the kernel of A. But usually we would also like to have a basis for A and express the kernel as some vectors so we can read out the dimension and we know which vectors are generating the kernel. So this is more convenient in most cases, so let's proceed here. So we can split it up into minus 1 over 5s, s and 0. So we extract the terms of s's, and then we also extract the terms of the t's inside. So we have then minus 3 over 5t, 0 and t. So you can see that this is exactly the same set. But this is helping us. So we can factor out s and t on both sides now. And then we have minus 1 over 5, 1 and 0 times s plus minus 3 over 5, 0, 1 times t, where s and t are real numbers. And now we have even vectors given. So this means this is the same as a span of minus 1 over 5, but we can also extend with 5, so we have minus 1. So if we extend with 5, we have 5 instead of 1, and here still 0. And here we can also extend with 5, so we have minus 3, 0, and 5. So this is the kernel of A. And now we are given even two vectors which are generating the kernel, and we can also see that the dimension of the kernel is 2 and generated by two vectors which are linear independently from each other. So if this video was useful to you, please consider subscribing to the channel, leave a comment, like the video, and see you next time.